Hello, this is Sharad. I will be today teaching you a topic in calculus which will help you in your IIM B UG Entrance examination. This is Sharad Avasti here. I'll be teaching you differentiation and application of derivative. And this particular class will be basically, uh, will be based upon doing questions only. We will do questions and we will do concept while doing the question. Okay, so let us get going. The first question, which is here in front of you, now this question actually deals with a concept of how do we compute when you cannot have y in terms of x directly. This is called implicit differentiation, which is not very difficult. Let me solve this question for you, and this is the way things will get revised also. Let us rewrite this: x into e raised to power xy is equal to y plus sine square x. Right, bacho? Uh, if I differentiate this, then here I'll use product rule. So what it will be, d by dx of x, and I'll multiply e raised to power xy plus e raised to the power xy will get differentiated, but I will have x without being differentiated. Here, right hand side, I'll have dy by dx, and here I will differentiate sine square x. It is so simple, right? Uh, all of you who have done, differentiation in class 12th will appreciate this. It is not so difficult. If I now differentiate e raised to the power xy, this is the function which I am differentiating. As we know, I'll get e raised to power xy as it is. And then this is a chain rule that I will differentiate uh, d by dx of xy. Wonderful. So this will become dy by dx. Now, this is, as you know, I'll again use the chain rule. This is 2 sine x into differentiation of cos x. Just be with me. It is not difficult if you have done differentiation a little bit. I'm also helping you to revise. E raised to the power xy plus x into e raised to power x by. Up now, if I differentiate xy, what do I get here? I'll get x dy by dx plus y. Of course, dx by dx will be equal to 1. Over here, dy by dx. And here I'll get 2 sine x cos x. So this is my result. Now, what to do? Dy by dx is coming very complex, so don't worry. Let's put x is equal to 0 here. If I put x is equal to 0 here, I'll get first term as e raised to power 0. Second term will become 0. Why? Because this is multiplied with x. Here it is dy by dx, but we can write here, bacho, at x equal to 0. Right? And this value will become 0. Now, what do we have over here? What do we have? This is dy by dx at x is equal to 0 is equal to 1. Wow, it is so simple. Nothing I have to do. In some question, this also can be asked where you have to find out the value of y. So at x is equal to 0, what will be value of y? Put it over here. You'll get 0, you'll get y, you'll get 0. So from here you will get y is equal to 0 when x is equal to 0. So this is also a trick which you could have used here, but it was not necessary to do here because this x was here in terms of, you know what, multiple. So as soon as x is equal to 0, this entire thing will become equal to 0. Hopefully you have understood the first thing, implicit differentiation. Please confirm. Good. Right. Now let us do the second part. See the beauty of this question which I have just taught you. अभी जो पढ़ाया आपको उसमें सबसे अच्छी बात थी कि हमें dy by dx लिखने की जरूरत ही नहीं पड़ी in terms of y and x. I have just put the value of x and y and got dy by dx. But one more thing, you should not compute y is equal to 0, y at x is equal to 0, sorry, y at x is equal to 0, and then differentiate. Then it will be wrong. You have to find dy by dx expression and then do it. Okay, let's do the next question. This question has been kept here because we can do logarithmic differentiation. Let us do this question. Logarithmic differentiation will get revised. So what we'll do here, it is looking complex. So before doing anything, I'll take a log. I'm writing ln because this is a natural log. Ln x raised to power m, y raised to power n is ln. Let me put a bracket so as to make it more clear. X plus y raised to the power m plus n. बिल्कुल ठीक है. So this will become m log x plus n log y is equal to m plus n. A little bit of computation is involved in this, but don't worry, it's not a difficult question. And then now differentiate. So what is the funda? If there is a complex term which has you know lot many powers, it make sense that we differentiate only after doing log of this. Now if I differentiate, I'll get m upon x plus n upon y, because log x ka differentiation is 1 by x, so log y ka differentiation is 1 by y, but y is not x, so dy by dx will remain here. Similarly, I'll have m plus n, you know and here I will have x plus y. So this is one term, and in bracket I will have d by dx of x plus y. So one more step I think we have to take on the right hand side. Let's do it. M plus n upon x plus y. Let's put this in a bracket. Here I'll get 1 plus dy by dx. So it's simple. I will put constant term at one side from here and dy by dx on other side. So let us do it, and let's use a different color. Let's use blue color here. So this will become m by x minus m plus n upon x plus y. This is coming from this side here, and this will go here. So this will be m plus n upon x plus y dy by dx. This is only this side, this one, this fellow, and this bhai is going that side. This part rather is going that side, n by y. So this is it, right? So this will become mx. I'm taking an LCM plus nx minus mx minus nx. This is ny. Let me erase it and rewrite ny. This is minus minus both upon x into x plus y. And what do we have on the right hand side? We will have dy by dx common. And in bracket again, this will get m plus n upon x plus y. Let me write it again. Let me not be, you know, unnecessarily fast in doing it. Minus n by y. Right, Bacho? Now here space is not there. I'll take my question here and I'll use a black pen. So when you're reviewing it, you can actually find out that this is the last step in the black part. This mx and mx will cancel. You will get here ny my minus nx, my minus nx upon x into x plus y. Be slightly careful, have patience, we'll just do it, okay? And here I'll take LCM, I'll get y into x plus y. So this is looking all right. This is not looking very odd. My plus ny minus nx minus nx minus nx. Let me use other space minus यहाँ से minus nx. This value is nx minus ny. This nx and ny, this nx and ny will get this ny and this ny will get cancelled. Let me now remove this part. and use this portion here. Slightly lengthier question. If this kind of a question comes, you should spare around 2.5 minutes to 3 minutes for doing this question. Now from here I'll get my result as mx minus ny. This is ny. This is not nx. This is ny. See from here, this is my minus nx. Sorry. So this is my minus nx. So that is what I'll write here. My minus nx into x upon x plus y. It is finished. This is the last step. It is only because of paucity of a space that we are doing it, slightly haphazard fashion. My minus nx. Wow, my minus nx and my minus nx has got cancelled. And this is y and this is x plus y. This is cool. So now what is the final value? Let me use this space over here. Dy by dx is equal to y by x. 2 to 2.5 minutes and we'll get our answer. Y by x. Understood? Clear? Let me ask my students over here. Is it clear? Okay, very nice. Thank you. Then let me do the next question for you. Oh, again, this is a question over here, which is on differentiation. So one more question. Let's do on differentiation. Then we will do application of derivative. Let's see whether we are able to do this question fast or not. Second order derivative we will learn here. Second order derivative. So we have done bachon implicit differentiation, logarithmic differentiation. Now we are studying second order derivative through questions. Very nice. So first is I always use ln. I don't use log with base e. That means natural log. You can also use this safely. That's a universally accepted way of writing mathematical logs. Okay, 1 upon x plus under root, because we are doing calculus, we are dealing only with natural logs. D by x plus, wow, अच्छा ये आएगा, yes, dy by dx is equal to 1 upon, this is, I'll use bracket now, under root. Bracket now is like a helmet. It will avoid accidents. Accidents means in maths mistakes. 1 plus d by dx of under root x square plus y square. You guys are smart. Under root x ka differentiation is 1 upon 2 into under root x. We will use that only. So what do we have over here? 1 plus 1 upon 2 under root the entire term. But again, this d by dx of x square plus a square is pending. Chain rule. So this will become 1 upon x plus under root x square plus a square. This is cool. It is mechanical only. This will get corrected. 2x upon 2 and wow, this is making sense now. This 2 and 2 cancel. This LCM will come, this will get cut. So this is simple. I have got my dy by dx, which is equal to 1 upon, let me see, kahin galat na ho jaye. Let me write the step correctly. If suppose dy by dx was asked, our problem would have been over by now. But no, they are not asking this. They are asking something different. So only step which we have been able to do is to find out this. Now I'll pause for 30 seconds. Let you note down this and then rub slowly. You can always play back and do this. Correct. Let me choose a black color now. Let me erase this. If you have not understood, please play back. Use the back key on your YouTube video And you can again see how I have come till this step of getting dy by dx is equal to 1 upon under root x square plus y square. Now I have to do what? As you can see in the question, I have to find out d2y by dx. So I will differentiate dy by dx. This is what is called second order differentiation. What will I get? I have to differentiate. Let me write this in terms of, you know, proper exponent. So this is minus 1 by 2. So this will give me minus 1 by 2. तो लगता है minus answer आएगा. Okay, minus 1 by 2. And this will become x square plus y square raised to the power minus 3 by 2. And then again I have to differentiate this fellow whose name is x square plus a square. That's good. Minus 1 by 2. Let me write it over here. X square plus a square raised to power 3 by 2. And this is 2x, this 2 and 2 will get cancelled. I will have here d square y upon dx square minus 1 upon x square plus a square into under root x square plus a square into x. Now my funda is clear. This x is going here and this x square plus y square is coming here and it will be equal to x square plus a square upon x into d2y by dx2, which is second order of derivative, is equal to minus upon under root x square plus a square. Now look at the answer. This value I have to find out, which is here. And this is minus, oh, from here, from this point, I can put this value minus dy by dx. So this is my answer. So have you understood, kids? So this, completes our revision and discussions on complex differentiations. We have done implicit differentiation, we have done logarithmic differentiation, and we have done differentiation which is of second order derivative. Please note all these questions are from different competitive examination. Let us now use this question to explain application of derivative. Yeah, saying application of dy by dx in rate of change. Okay. So what is given? Rate of change of area of a circular disk. Area is pi r square. With respect to circumference, let us call it C. Let us call this is 2 pi r t. So they are trying to ask us dA by dC when r is equal to 9. So this is simple. I will start this question by first finding out dA by dt, which is equal to 2 pi r dr by dt. And then I find out dc by dt. C I have taken to replace this term circumference. This will be equal to 2 pi dr by dt. From here, I'll get dA by dc. Of course, I will divide these. This dr by dt will get cancelled out and get r. So dA upon dc at r is equal to 9 will be equal to r. So when radius is 9, this is getting changed at 9 centimeter per second. Why centimeter per second? Why centimeter? 9 centimeter, no seconds. Why? Because second has got cancelled and it is area with respect to circumference. So this is rate of change concept. Let us now do this question also. This is also rate of change. What does it say? A spherical iron ball of 10 centimeter radius is coated with 5 centimeter. So this is 10 and this is 5. So what is this total this thing? This total value is equal to 15. So ice plus iron ball have a total radius of 15 centimeter. Okay. At that point, I have to find rate of decrease. What is given to us? dv by dt, which is equal to, rate is decreasing, we'll use minus sign, let's say, to be more accurate or correct. If you don't take minus sign, it is okay, but it is decreasing, so melting. So you can take volume is shrinking, you can take negative sign. Okay, bicho. I have to find dr by dt when r is equal to not 5, but r is equal to 15. So this is my comprehension of the question. Now, which formula I'll use? V is equal to, for a sphere, 4 by 3 pi r cube. Here now differentiation kicks in. This is 4 by 3 pi 3 r square dr by dt. This 3 and 3 will get cancelled. You will get 4 pi r square dr by dt. Now let us put those values. R is equal to how much? 15. So I'll put 4 pi 15 ka whole square. Here I'll put dr by dt, which I have to find out. Here I'll put minus 50. Now let's solve it. So dr, I have written dr by dr, ऐसे तो कुछ नहीं होता है. dr, अच्छा है तो राइम कर रहा है. dr by dr ऐसा कुछ नहीं होता है यार. Very nice. Minus 50 upon 4, and this 15 ka whole square, let us treat is like that only, or should I? Yeah, let us write 225. That's easier comprehensible by you guys. And here pi. So this 25, this is 9, this is 2, 25 दोनों के cancel किया, this is 2. So what I'll get? Minus 1 upon 18 pi. Second is the answer. It is only coincidence that we're doing questions where we're getting always option 2 as an answer. Let me see. Understood? Yeah. Yes, minus. Why minus sign was not there? Because it is saying rate of decrease. So they don't have to give minus sign, because here they are showing rate of decrease. What will be the answer? 1 upon 18 pi. So let's go and solve next question. This relates with slope of tangent. I know this is a chapter which has been taken out from NCRT, but this can creep in somehow or the other. Slope, how it can creep in? It can creep in because you read coordinate geometry and so on and so forth, and you read tangent. So there's no harm in knowing the slope of tangent is equal to dy by dx at that point. Which point? At which tangent is drawn. So dy by dx at x1 comma y1. So this is the entire concept. Student have this wrong impression that dy by dx is slope of tangent. No, dy by dx ka value at x1 comma y1. So here slope of tangent will be equal to dy by dx at x equal to 2 and y equal to 3. This is very important. So now let's compute dy by dx. This will be equal to 2y into dy by dx. That's how we'll differentiate. This will be 3px square. So what do we have here? I'll put those value 2 into 3 dy by dx. What values are you talking about, sir? I'm talking about this value. And this is 3p, and this is 2 ka whole square, which is 4. So dy by dx will come to us, this 3 and 3 will cancel, will come as 2p. Wow, this is at x equal to 2 and y equal to 3. So this is my slope of tangent. As per question, if you see and compare with y is equal to mx plus c, you will get slope as equal to 4. So from here, this slope is also of tangent and this is also of tangent. So 2p is equal to 4 bacho. So p is equal to 2, that means this answer or this answer. P is equal to, now how to get y? We got stuck. No, this 2 comma 3 will satisfy this. So let us satisfy this 3 ka square. Let us do put these values 2 and 3 over here. This 2 and 3 over here. I'll get 3 ka square is equal to p into 2 ka cube plus q. What is the value of p? We have got 2. So 2 into 8, which is 16, plus q is equal to 9. Oh, wow, we have got the answer. This is incorrect. This is my choice. Question number 2. Q is equal to 9 minus 16, which is equal to minus 7. So this is also a concept, I think, which you should recall and remember. So now we are through with application of derivative में two things. One is slope of tangent and other is rate of change. Right? Now let us come to this part in which we are dealing with. This is a question which deals with maxima and minima. Right? So now two things are pending: maxima, minima, and monotonicity. So let's do monotonicity first. Monotonicity का क्या concept है? Let us revise this. If function is strictly increasing, right? Strictly increasing. This means only one fact. This means f of x1 will be greater than f of x2 if x1 is greater than x2. For differentiable functions, बच्चों, this condition transforms into f dash x being greater than 0. So most of the time this is strictly increasing condition and we are dealing with most of the time, differentiable functions. So this conditions has got, twin interpretation. ये दोनों सेम से लगते हैं. Strictly increasing मतलब f dash x is equal to 0 and also strictly decreasing. So this is strictly increasing, right? So what is strictly decreasing function? I'm sure you would have rhymed, you would have answered the rhetoric f dash x is less than 0. Okay, so let us now use that concept here and solve this question. If fx is equal to half x square minus x, we can write f dash x is equal to 2x by 2 minus 1, which is nothing but x minus 1. So what we do, we will try to draw a number line over here. This is minus infinity and this is plus infinity. And what am I trying to do? I am drawing sign scheme of, I have taught you this earlier in my earlier lectures. जैसे y का साइन स्कीम निकालते थे वैसे ही f dash x का साइन स्कीम निकाल रहे हैं. There is only one root, x is equal to 1, which is plus. इस जगह पे 0 है, 0. Here it is plus more than 1 and here it is negative, which is minus. If it is so, that means curve is first decreasing and then increasing. It is just for the illustration purpose. Here it is strictly decreasing and here it is strictly increasing. Like this, you know. So what is like it is a underpass. So what it will have? It will have a local minima at x is equal to 1. So at x is equal to 1, it has a local minima. Is it decreasing strictly in 2 to 1? Decreasing? No, it is increasing. So this is incorrect. It is attaining maximum value? No, it is attaining minimum value. Is it increasing? Minus infinity? No, sir, it is decreasing. So all three were wrong. This is correct. And you know what? I have taught you over here first order derivative test. What is first order derivative test now? If it is decreasing to increasing, then it is minima. if suppose माइनस टू प्लस हो रहा है then it is minima. If suppose प्लस टू माइनस हो रहा है, overbridge बन रहा है, then it is maxima. So I am sure it is just a recall for you, and you guys are aware of this first order derivative test for finding point of extrema. Let's do the next question. Okay, this is also increasing and decreasing question. Look at this. Slightly, slightly tougher. Maybe not tougher. This is a kind of question, kids, you can get in your examination. F dash x, or this is also written as d by dx of fx. Okay, that means I have to differentiate. So for increasing, decreasing, or finding minima or maxima, I have to find f dash x. Remember, increasing matlab f dash positive. Okay, decreasing matlab f dash x negative. Very nice. 3x minus 7 into x raised to the power 2 by 3. Let us do a little bit magic here. Let us multiply inside. So 3x raised to the power 5 by 3. Otherwise, I have to unnecessarily use, product rule. Why to use that? Right, like this. So what do we have here? 3 into 5 by 3, and x raised to the power 5 by 3 minus 1. And what do we have here? 7 into 2 by 3, x raised to power 2 by 3 minus. Oh, minus 1. Negative ho gaya. Okay, no problem. This is 5. This is x raised to the power 2 by 3 minus 14 by 3. So 14, 15. हाँ दिख रहा है दिख रहा है दिख रहा है. And this is x raised to the power minus 1 by 3. This is what? F dash x. You know what? This prime notation was used by Newton, and d by dx is used by Leibniz. So Newton and Leibniz are the mathematician who has given us the gift of, or the curse of, whatever the way you see it, of differentiation and integration. So they used to use these two alternatively. This is Newton and this is Leibniz. Both are used. You can use both. 15 x raised to the power 2 by 3 into x raised to power 1 by 3 minus 14 upon x raised to the power 1 by 3. I have solved it. X raised to power minus 1 by 3 को I have written 1 upon x raised to power 1 by 3 to LCM. है ना बच्चों? So this will become, this is cool, 15x minus 14 upon x raised to power 1 by 3. Now I have to make my sign scheme. F dash x. So this is 15 common, x minus 14. Let us multiply and make it, even power over here. X raised to power 1 by 3 ka whole square, so that this sign denominator will come in a numerator. I have multiplied x raised to power 1 by 3. So it has two roots. Which one, kids? X equal to 0 and x is equal to, sorry, my mistake, 14 by 15 here. So this is 14 by 15. Let me write it clearly so that you find it good enough. 14 by 15. So this is 14 by 15. Two roots. This is plus, this is minus, this is plus. How does the function operate? Decreasing? No way. This is plus. So it is increasing, negative. So this is decreasing and this is increasing. There is a local maxima, here it is local minima, but this is not asked. It is asking where it is increasing. It is increasing from minus infinity to 0. This is the reason. And 14 by 15 onwards. So 14 by 15 onwards in maths is written like this. These are the two values. Let us see where are these values. So my term is increasing consistently, right? If we have to do, put some values. Let's put x is equal to 1 and x is equal to 2 to find out. If I put x is equal to 1, fx will be, minus 4. If I put x is equal to 2, fx will be minus 1. into 2 raised to the power 2 by 3. Of course, this value is less than this. That means if ये बढ़ रहा है, so this is, you know, also increasing. Minus 4 say minus 2 raised to the power 2 by 3 is gone. Okay, so cool, we have done it, we have, you know, checked also, so not a mistake. We are okay, we are cool. Okay, so that is where it is. Okay, so minus 40, very nice. So please note it down. You have to find out f dash x. After f dash x, you have to write sign scheme. The sign scheme is a wonderful thing. I have used in domain and range. Now I'm using it in maxima and minima and and monotonicity of function. That is whether it is increasing or decreasing. Understood? Clear? Okay. Right. Let's go to the next question. Let me see the remarks. Yes, understood. Let me go to the next question, which is here. Find the local maximum value of this. Wonderful. Fx is equal to 2 by x square. Acha ji. Again, I have to, you know, these powers are there and I have to find f dash x. How do I find f dash x? Or for that matter, d by dx of fx. As you have noticed, and I have taught you, we will use logarithmic differentiation here. Otherwise, we'll not be able to find. Okay, so we'll write ln fx is equal to x square ln 2 by x. Let me do a little bit, you know, ln 2 minus ln x. Let me write it like this. So this will become x square ln 2 multiplied by ln 2, which is a constant term. Here I have to use product rule. Okay, no issues. I'll do that. Ln fx. Now I will differentiate. I'll differentiate both the sides. Why am I doing it? Come on, I have to find out f dash x. How else do you think I'll be able to do this? Ln 2 into x minus d by dx of x square into ln x. This is 1 upon fx. Wow, this is f dash x has come. This is the fellow I was, you know, aiming for. Now, let's solve. Ln 2 is here. Dx by dx is 1. This will become 2x into ln x. That you use bracket because this plus will come. This is a product rule. So this will be x square into log x ka differentiation is 1 by x. Not bad. So this is 1 by fx into f dash x, which is not so bad. Log 2 minus 2x log x. Let's put it in bracket. Plus x. So this is where we are now. Okay. Now for this f dash x, I will write like this: fx into ln 2 minus x common 2 log x plus 1. Okay, right? If I draw a sign scheme, right? So I'll get f dash x equal to 0 when for up now I have to use, you know, the other part of our uh, screen. Okay, f dash x is equal to 0 is the main point over here. That is where I'll get my local maximum value because I have seen f dash x has to be 0 for point of extrema. Not necessary, but it looks like this will help us. So f dash x is equal to 0. because fx is never 0. Why? Because x is greater than 0, the system is always positive. So for f dash x is equal to 0, you will get log 2 minus x into 2 log x, which can be written as log x square plus 1. This must be equal to 0. So this will become ln 2 is equal to x log x square plus 1. Understood? Clear till this point? So we are very close to finding out the value of x. What is that? We are close to, kids, finding out the value of x. This value of x, I'll put this value of x, I'll put where? I'll put this value of x in this value of x, I'll put in f of x, right? Because it is not asking where exactly you are getting, at what value of x you are getting function being having a maximum value. So just give yourself a second, right? And find and just note it down. What are the steps? I will start with fx. This is the last question which we're doing in this class, because this is the last application of derivative, that local maximum value. How do we find out? Okay. So let us revise. Fx is equal to this value, 2 by x raised to power x square, right? I'll find out f dash x. For finding out f dash x, I have to do this x square into ln 2 minus ln x. I have solved this. I'll got x square, x square ka value is equal to 2x. This is x square. So here, this is the thing which we're missing here. This is 2x, right? So let us revise this 2x, right, bacho? This is here 2x. Okay, so f dash x will get slightly reformatted. Have you understood why did I get 2x? Because x square ka differentiation is 2x. It is not 1. If it has been x, then it would be okay, right, bacho? So this is 2x ln 2 minus common ln 2 minus ln x plus x, okay, into fx. Now please note f dash x a little bit more computation. I will take x common, so this will become x into f of x, and here I'll get 2 times ln 2 minus ln x plus 1. Wow, now I have got my sum. X cannot be equal to 0. This is positive. This is positive. So now what do we have? We have here, I'm using this space for f dash x is equal to 0. I will have 2 times ln x, 2 times ln 2 minus ln x plus 1 will be equal to 0. Okay, right? 2 times this plus 1 equal to 0. So we'll solve it. I'll get minus 1 by 2, right? Over here, just from here you solve it. This is plus 1. This is equal to 2 ln x minus x. So this is minus 1. So this will be minus 1. This is plus 1 by 2 ln 2 minus ln x. What is the thing which we are getting from here? I'm getting the value of ln. बच्चों ध्यान से देखना, ln 2 by x is equal to 1 by 2. This is necessary for this. From here I'll get 2 by x is equal to e raised to the power 1 by 2. Wow. So this I'll put here. So my maximum value will be equal to 2 by x की जगह e raised to the power 1 by 2, e raised to the power 1 by 2, right? And then I will put the value of x. What is the value of x? X ka value is 2 upon e raised to the power 1 by 2. So what will be the value of x square? A little bit of log necessary. 4 upon e. I'll put 4 upon e here. So now this value will come, bacho, e raised to the power 2 by e, my fourth answer. Right? If this question comes in your IIM B UG examination, just be away from this. Okay, right? Why? Because it will check all your concept of differentiation. But if you have to understand differentiation, application of derivative, I think this is the question which you must solve. Okay, and if you solve it well, redo it, practice, playback, do it again, and I'm sure you'll be able to do your questions of differentiation and application of derivative in your IMB examination. So, as per my thought, you must be clear about implicit differentiation, you must be clear about logarithmic differentiation, you must be clear of second order derivative, you must have done application of derivative, that is application of by dx in finding rate of change, important one, increasing decreasing function, important one, and finally maxima minima value by doing first order derivative test. Students ask me what should I do in calculus. This is what you should do in calculus. You might get one or two questions from it. Thank you very much. Let me see my students over here. Got it? Yeah. Okay. Right. So we are at a close of our session. Thank you very much. Please revise, as I have told you, you'll get benefited in your IIM B UG Entrance examination. So see you in on Thursday for a session on integration. Bye bye. Take care.